So let's begin and let's take a look at what the situation looks like if we want to take and pick up our phone and move to a different site without device mobility. So here we've got an example of a guy holding a 7921 wireless phone, 802.11, BGN, whatever, wireless phone. And in the module we're going to use today, we'll be physically moving our 7961 hardware phone, which wouldn't be what you would typically do in the real world. You would have either a Nokia dual mode GSM and 802.11 phone, or you'd have something like this, a 7921 phone. And this is these are by far the two biggest reasons that device mobility was incorporated. But the truth is, it could be anything. It could be CIPC soft phone. It could be CUPC. It could be you could be moving your hardware 7961 or 8900 series phones, what have you. So we'll take a look at it. But here we see that this guy wants to. It looks like he's running out the door from the corporate headquarters, Seattle, Washington site in the U.S. over to the branch 1, Austin, Texas site in the U.S. So let's take a look here. Car comes and gets him and picks him up and takes him to the branch 1 site. And then he wants to go and dial a number like he would have dialed from his corporate headquarters site. So from his corporate headquarters site, in order to get to this PSTN phone that we see up at the top right here, +31, which is our branch 2 site in the Netherlands, and then 20, so the city code of Amsterdam, and then 703-7333. This is a phone out on the PSTN. He goes and he's going to dial 9011-31-703-7333, but without device mobility, the call gets sent over the WAN, and because his device pool for his 7921 was corporate headquarters, and so is the gateway at corporate headquarters where his call would go out because of his device calling search space, line calling search space. Remember, line typically defines the class of restriction, and device typically defines site selection or site-specific gateway that will be used without looking at local route groups or anything like that, or even just looking at the calling party being himself. Local route group without device mobility would be his corporate headquarter gateway. So because the region in his 7921 corporate headquarter device pool and the region for the corporate headquarter gateway where his call is going to go out are the same region, we typically and by default have G711 or G722 if negotiated, but G711 within a region. So his call goes across the WAN. G711 uses a lot more bandwidth than WAN calls are traditionally expected to use, and goes out the corporate headquarter gateway, while he could have just sent the call directly out his branch 1 gateway where he's now visiting. So without device mobility, the PSTN call uses the home gateway. The location-based CAC, or call admission control, is unaware of the call. Now we might pause and say that if we were using RSVP-based locations, rather than just traditional location-based CAC and CUCM, if we were using RSVP-based locations, this would take care of the problem in the sense that RSVP, call admission control, would be path-specific. It's in-band, essentially, or in-line call admission control. So it would be aware, first, that it was a G711 call, and then also that, to reserve the proper bandwidth if there was bandwidth available. But traditional locations-based CAC won't take care of it. G711 codec, as we already mentioned, uses more WAN bandwidth. The home site, something else we haven't mentioned, the home site's media resources are going to be selected. If he went to set up a conference between himself and, let's say, someone out at a branch 1 site, not only is he going out the corporate headquarter gateway, but he's going to be using conference bridge resources across the WAN again, so possibly more bandwidth being used for multi-party conferences back at the corporate headquarter gateway. Then AAR, if needed to be invoked, would be anchored on the home gateway. Again, RSVP would allow call admission control to properly know the status of the call, and therefore AAR possibly could work, but it's going to be anchored on the home gateway. And if he's trying to call out a local gateway because there's not enough bandwidth across the WAN, well, then that's just going to fail. So let's take a look at the same scenario, but with device mobility. So with device mobility, car comes and picks him up and takes him over, and he dials the same number, 9011-3120-703-7333. This time, it goes out the local gateway. So this is because the PSTN call uses the roaming gateway. He basically adopts much of the parameters of the visiting device pool. Location-based CAC, traditional location-based CAC, is aware of the call. Obviously, RSVP still would be as well. There wouldn't be any RSVP because we're not ever traversing a WAN link. But traditional locations would still work properly. WAN bandwidth is not consumed in any way, not in this scenario. The proper media resources are selected, so he, again, inherits much of the characteristics or parameters of the visiting device pool. We'll take a look at this specific in a moment with our tasks. And AAR, since he's going to adopt new parameters, AAR is going to allow outgoing calls would be sourced on the new site's gateways. Okay? Incoming AAR calls would fail. So keep in mind, if an incoming call were to be routed via AAR. Now, this is not necessarily saying that a regular inbound call to his direct inward dial number would fail, but just if an incoming call happened to be routed because of AAR, there wasn't enough bandwidth between the corporate headquarter TDM PSTN gateway, where the call's coming into his DID, and always will, because that's where the carrier will route it, and there's not enough bandwidth between that gateway and the remote site that he's visiting. Okay? If that's the case, locations or RSVP-based locations cause the call to fail, then the incoming AAR call would fail because, well, the call would be coming in the PSTN home gateway, but there's not enough WAN bandwidth over to his branch site. Okay, but if there is enough bandwidth, then the incoming call would set up properly. So device mobility is going to determine that a device has moved to a new location based on the device's IP subnet, its home subnet, and any new possible subnets that it knows about. And we'll get into some of the specifics about how it knows about subnets and what we can do to make sure that it always knows about where a phone's location is, sort of a default location for all phones. It dynamically associates roaming device pool to the devices that move to a different location. Determination to extend certain features are based on the following parameters. The question is asked, is the device roaming outside of its physical location? If the answer to that is no, then no updates are going to be sent to the IP phone's settings. Okay, so no IP phone device settings will be updated. So in other words, it might be roaming to a new subnet, and it might even, that new subnet might even be tied to a different device pool, but if the physical location is the same, and we'll see where we associate this, then no settings will be updated. We'll use all of our home settings. If yes, if a subnet shows that we've not only moved to a new device pool, but the device pool also has a different physical location than its home location, home physical location, then we ask one additional question. Is the device roaming within its device mobility group? If it is roaming within its device mobility group, then all of the parameters of the visited device pool get passed to the IP phone. If it's not roaming within its device mobility group, its home device mobility group, then only some of the parameters of the visited device pool get passed to the IP phone. There's a real good reason and explanation for this, and after we take a look at the next couple slides, hopefully this will help clear some of this up. So first of all, before we go on to the next slide, let's just reiterate, if the device mobility, first of all, device mobility mode has to be on for a given phone. Otherwise, not all phones by default, and we can turn this on in service parameters, but it's not advised to do so. It's not advised to make the default device mobility mode set to on, because then every single time every phone boots up on the system, it has to go through checking subnets, and it basically adds load to the CPU of all processing engines. It's advised that you only turn it on for the phones that are going to be roaming. So, this would most likely be your soft clients, your 7920 or 7921 phones, and any wireless phone, whether a dual mode. So any wireless or soft client phone, to sum it up, you could go through bulk administration tool, do a custom query that checked for soft clients, CUPC, CIPC, wireless phones, and turn device mobility on. But if it's on, if it is identified as a different subnet than its home subnet, however, at the device pool level, it's tied to the same physical location. So in other words, maybe, what might be a good example of this? Well, I'm looking out my window and I see another building here across the parking lot in my same office complex campus. If I were to, head down the lift, head down the elevator, and go out my building and take my 7921 wireless phone over to the other building over here, and once I associate with an AP, then there's going to be a subnet. Maybe I've got one subnet per floor if it's a rather large building. I get up to the third floor of the other building. I finally associate with the wireless AP that I'm going to be at for a while, visiting for maybe an hour or two for a meeting, and CUCM sees my new subnet. It sees that it's tied to another device pool, building 2, but it's the same campus, the headquarter corporate campus or Columbus campus. And so maybe, just depending on how I've got my system set up, maybe I've got it set up so that, I've got bonded 10 gig fiber links between buildings. So I'm going to consider all 3 of these buildings within this, parking lot, within this campus, to be on the same physical location, even though they have different device pools. So I get to my roaming, I guess I shouldn't call it roaming, I get to my, for lack of a better term, roaming subnet, certainly not my home subnet. A new device pool is associated with this subnet. However, it's tied to the same physical location. And so because of this, I essentially see that my physical location has not changed, and the reason I set it up that way is I had tons of bandwidth between buildings, and maybe all my TDM gateways are in one building anyhow, and so no new parameters from my device pool, the visiting device pool, get passed. Why? Because I can afford to have all calls go across the IP infrastructure back to my home building and out my home gateway, because it's not even really a WAN, it's an extremely high-speed LAN. So that might be one reason that you might want to design it in that way. But again, you can design it however you want. So if it's inside of its physical location, no parameters get passed. If it's outside of its physical location, then we'll look at the next slide. Does it roam within or outside of its device mobility group? So, is the device roaming within its device mobility group? And really, if we're going according to the way that Cisco has design parameters set up, we will go ahead and make the connection or association between the nomenclature of device mobility group, is what Cisco CUCM calls it, and just the idea of a country, of a nationality. And for, country code of 1, really numbering plan code of 1, this would actually be the US and Canada together. Even though they're separate countries, we use the same numbering plan, we use the same fashion to dial. But let's say, we're going from the US to the UK, or from the UK to Australia, or from Australia to India, or from India to the Netherlands, or from Netherlands to Germany. Between these, we all have very different ways of dialing. Okay? So, because of this, we're going to consider each of those separate countries and separate device mobility groups. So we'll create one device mobility group per country or per numbering plan. Now, this isn't a rule that you have to follow, but once you understand why it's set up like this, I think it will make a lot more sense. And also, once you understand what all we can do when we get through our tasks today, I think you'll understand that this will still be very flexible with our ideas of globalization. So if we're roaming within our same device mobility group, or we're roaming within the country, we're between physical sites, maybe between cities even, but within the same country or device mobility group, then all of these visited device pool parameters get updated. Local route group gets passed. Date time group, region. Okay, so we get a new date time group, very likely in a new time zone, or very possibly. Depends on how big the country is. New region, so that codecs can be treated differently. WAN calls, I should say calls, between a phone that used to be on the same home subnet, maybe I'm moving from corporate headquarters to branch 1, and a call from corporate headquarter phone 1, which is now roaming over at branch 1, and corporate headquarter phone 2 used to be G711, but now because I've taken new codec and new regions on my corporate headquarter visiting phone 1, I'll use a new region, and then a call back to the corporate headquarter phone 2 will be G729 because it's actually going to be a WAN-based call. So I get new regions, I get new media resources, hopefully that are local to me, new location for locations-based CAC, or even RSVP-based locations. I know which RSVP agent or MTP, RSVP-based enabled MTP on an iOS router to trigger first. A new SRST reference, new physical location. Actually, the physical location is the differentiating factor. The device mobility group. So the physical location and device mobility group don't really get updated. Those are the really the determining factors that we'll take a look at here. Then we've got our device mobility calling search space. So this is the calling search space that will be replacing the CSS that's on the device. So as I move my physical device, I'll actually get a new CSS at my device level. And this is what will allow site-specific call routing. My AAR calling search space, again, if I'm moving my physical site, then I don't want to use, or possibly don't want to use, in this case it'll work just fine, possibly don't want to use the same AAR CSS as I had before because I want it to go out a site-specific gateway. Again, with globalization, we can still have just one AAR CSS and one AAR group, just as we looked at back in module 11 for unlocking the potential of globalization and localization. This will still work just fine. And we'll take a look at an example of it in the tasks. But a calling party transformation CSS. It's very possible that I, as a headquarter phone, want the new branch 1 phone calling party transformation pattern, mask, or CSS to match patterns because I want numbers to show up to me in a way that's local to my new location. Called party don't really matter for phones. They only matter for gateways. If a call has actually been extended to a phone, we never need to transform the DNIS because it's already reached its destination. We only possibly need to transform the ANI. So this is within a country. Now let's look at if we're between countries. And this red line should have actually been extended up just a little bit. So if we are roaming to a new subnet, a new physical location, but outside of our home device mobility group, so outside of our home country, then we still want, first of all, local route group. I should have extended that red box up just a little bit. The local route group will be passed or inherited or updated its settings. Obviously, our date time group, our region, media resources, locations for CAC, SRST. However, if we look down at device mobility related information that was in the red highlighted area earlier within a country or within a device mobility group, why would we not want these parameters to be passed? Well, think about it. If I'm in another country and I take my mobile phone with me and let's say I've got a GSM SIM card, but it's not a GSM SIM card of the visiting country. I just, take my existing GSM phone to another country and power it up using my home SIM card. Then what's going to happen? Well, my date and my time are going to show up properly because that's going to be associated to the roaming mobile cell tower. My calls will use whatever their cellular network tells me in terms of a codec, so sort of regions. But when I actually come to my dialing habits, if I am used to dialing, let's say 01144 to get a call out to the UK on my mobile, or maybe I just do +44, maybe I do plus dialing, but I'm in the UK, I still should be able to dial in the exact same format. And this becomes much more so important with users that, and you have to take yourself outside of the engineer mindset, the mindset that you're more than even just a power user with an IP phone or with a phone system, that you happen to know other countries' dialing plans, but put yourself in the position of an average user that just was given a 7921 phone and told, when you get to our London office or our Amsterdam office or our Paris office or whatever, fire this up and then use it as normal. So you get to those other 3 offices because you're actually visiting all 3 cities, and without having to know how each country dials, because maybe it's your first time there, you don't know how the local dialing plan works. You just use your phone as you always have. Educated about dialing plans or phone systems, it's your first trip outside of wherever your home country is. So you don't or shouldn't need to know about the new dialing plans. You should be able to retain all of your dialing habits. And if you do this, you're going to need to keep your same device calling search space, because if you inherit a new device calling search space, well, then there's going to be a problem, because you're going to have to dial in the fashion of your visiting site's, PSTN code. So maybe they dial 0 for secondary dial tone in an outside line, and you're used to dialing 9. Maybe you're from the UK and you're visiting over to Australia. You've never been there before, and they dial 0 for outside dial tone, and then 0011 for international, and you're used to dialing just 00 for international. So you would dial 000, and they actually dial, maybe you dial a 000 and then a 1 to dial internationally to the U.S., but they dial 000 and 111 to reach the U.S. So without having to know those new dialing habits or having to ask someone or repeatedly have to ask someone if you have to make multiple calls, you should be able to retain all your same dialing habits. So this is the reason that if we stick with the design that Cisco recommends, that device mobility groups equal countries, then our device mobility calling search space, or the CSS that would otherwise replace the CSS on our device, it does not replace anything, neither does our AAR CSS, nor our AAR group, nor our calling party transformation CSS. Okay? So phones would still go out your primary home gateway or phone calls. They would, your dialing habits would be retained. Now, of course, we can manipulate the design knowing what the individual pieces of the puzzle, knowing what the tools do. We can manipulate the design anyhow we want. So if all of our users are very educated users of every remote country that they're going to visit, well, then we could just simply create one device mobility group for our entire CUCM system, regardless of what country they'll be visiting, regardless of how many countries we have CUCM cluster branch sites in, or branch sites off of our main cluster. And then we would always get the new CSS, AAR CSS, AAR group, and calling party transformation CSS. Okay, so we do have that ability. Does anyone have any questions, or does that make sense to everyone? How device mobility groups equal country, and the reason is so that we can maintain our traditional dialing habits?